let A, B, and C be finite sets. In this video, I'm going to show that the cardinality of A union B union C is equals to the cardinality of A plus the cardinality of B plus the cardinality of C minus the cardinality of A intersection B plus the cardinality of A intersection C plus the cardinality of B intersection C plus the cardinality of A intersection B intersection C. And then I'll go on and consider the integers 1 to 300 and find the integers in this range that are divisible by at least 1 over 3, 5, or 7. So I'll start by showing that this expression here is valid. To show that, I'm going to use the principle of inclusion and exclusion for two sets. It says that the cardinality of A union B is equals to the cardinality of A plus the cardinality of B minus the cardinality of A intersection B. So on the left-hand side there, we are having the cardinality of A union B union C. I can put the B union C in parentheses, then we'd have the cardinality of A union B union C. So looking at this part here that I've put in the parentheses, I can take it to be my B in the principle of inclusion and exclusion. So we have the B here, and B here, B here. I will replace it with this B union C. So our expression will become the cardinality of A, then plus the cardinality, then plus the cardinality of B union C, minus the cardinality of A intersection B union C. Now looking at this part here, we are having two sets B and C. We are taking their union. We can use this principle of inclusion and exclusion. So in the principle of inclusion and exclusion, where we are having the A, we'll replace with the B. Where we are having the B, we'll replace with the C. So our expression becomes the cardinality of A plus the cardinality of B plus the cardinality of C minus the cardinality of B intersection C minus the cardinality of A intersection B union C. So that's the expression that we are having now. But I can go on and look at this part here. We can expand that using the distributive law. So for the parts that are to the left that are not highlighted there, I can just write them as they are. So we have cardinality of A plus cardinality of B plus cardinality of C minus the cardinality of B intersection C. And this part here, I'm saying I'm using the distributive law. So whatever the cardinality of A intersection B union A intersection C. Now looking at this part here, we can take it as one set. And this part here, we can take it as another set. So it will be like we're having two sets so that we can use the principle of inclusion and exclusion. So I'll go on and write the parts that are not highlighted because they are not changing. So we have the cardinality of A plus the cardinality of B plus the cardinality of C minus the cardinality of B intersection C. Then we go on and apply the principle of inclusion and exclusion. This one here, we are having two sets A union B. In this case, we will say that this part here will be our A and this part here will be our B. So our expression becomes the cardinality of A intersection B plus the cardinality of A intersection C minus the cardinality of A intersection B intersection A intersection C. Now looking at this part here, I can put it inside of these brackets here. And then go on and look at this part here. We can simplify that using set laws, both A intersection B intersection A intersection C. That will give us A intersection B intersection C. Since we would have that A intersection A will give us an A. So our expression becomes the cardinality of A plus the cardinality of B plus the cardinality of C minus the cardinality of A intersection B plus the cardinality of A intersection C plus the cardinality of B intersection C, the one that I put in the brackets there, this one. But now looking at this part, we have a minus sign. And on this part, we also have a minus sign. So when you multiply those two minus signs, it will give us a positive. So that our A intersection B intersection C becomes a plus. So it will be plus the cardinality of A intersection B intersection C. So what we have now is we have shown that the cardinality of A union B union C is equals to the cardinality of A plus cardinality of B plus cardinality of C minus the cardinality of A intersection B plus cardinality of A intersection C plus cardinality of B intersection C, then plus cardinality of A intersection B intersection C, which is what we were required to show. So I now move on to the second question there. We are looking at integers in the range 1 to 300. And we want to find integers in this range that are divisible by at least 3, 5, or 7. At least one of 3, 5, or 7. We can write this using a set notation, and it will be the cardinality of S3 union S5 union S7, where the S3 there are integers divisible by 3, S5 integers divisible by 5, S7 integers divisible by 7. So to evaluate that cardinality there, we will use this expression here that we have just evaluated. So where we are having the A, we will put the S3. Where we are having the B, we will put S5. Where we are having the C, we will put S7. So our cardinality becomes the cardinality of S3 plus cardinality of S5 plus cardinality of S7 minus the cardinality of S3 intersection S5 plus cardinality of S3 intersection S7 plus cardinality of S5 intersection S7, then plus the cardinality of S3 intersection S5 intersection S7. We now go on and evaluate the cardinalities which are in this expression here. We are looking at integers 1 to 300. So when you are looking at the cardinality of numbers that are divisible by 3, it will be the floor value of 300 divided by 3, which will give us a 100. For the cardinality of numbers divisible by 5, it will be the floor value of 300 divided by 5, which will give us a 60. For the cardinality of numbers divisible by 7, it will be the floor value of 300 divided by 7, which gives us a 42. For the cardinality of numbers that are divisible by 3 and 5, we'll be saying the cardinality of S3 intersection S5. Divisible by 3 and 5, they are divisible by the product of 3 and 5. So it will be the cardinality of S15. The cardinality of S15 is the floor value of 300 divided by 15, which will give us a 20. For the cardinality of S3 intersection S7, it will be the cardinality of S21. Both multiply the 3 and 7, which gives us a 21. And that will be the floor value of 300 divided by 21, which will give us a 14. For the cardinality of S5 intersection S7, we multiply the 5 and 7, we get a 35. So it will be the cardinality of S35, which gives us the floor value of 300 divided by 35, which gives us an 8. For the cardinality of S3 intersection S5 intersection S7, numbers that are divisible by 3, 5, and 7 are divisible by the product of 3, 5, and 7. So 3 times 5 times 7 gives us 105. So that cardinality there, it will be the cardinality of numbers that are divisible by 105. And that will be the floor value of 300 divided by 105, which gives us a 2. And now we go on and substitute these values here into this expression, so that we would have 100 plus 60 plus 42 minus 20 plus 14 plus 8, then plus 2. Then when you go on and simplify that expression there, we would get that is 162. So we are having in the range 1 to 300 the numbers that are divisible by 3, 5, or 7 are 162.